We'll do this. So we designed this system, made a few steps, it's going to detect, it's going to scream loud, we know that there is a duck, it's going to get that bastard. Now take it away from this.
Today, the most important thing about this system is obviously ensuring the safety of the officer and checkpoint. So that I implemented algorithms to calculate quite a few things so we can get as much data into the officer's hands as possible. So our sensor is going to go back and forth, and using that, I can calculate when it first detects the duck, first detects the edge of the duck and the end of the duck. I can use those two angles and the distance to that duck to calculate the size of the duck and how far away the duck is. Using this, I'm able to display a representation on where on the table the duck lies, and display how the size of the duck and how far away the duck is. This will allow so we can differentiate if it's a large duck, a small duck. Is this something the security guard needs to be extra worried about? Is this something they like extra people on hands to handle, or is it something they can just kind of walk in and check out what's going on? To implement gathering the data that I need for my algorithm to calculate all that, Kieran handled that.
Okay, so to get the data to run its algorithm, we've mounted a servo back here that will spin 180 degrees to scan the whole table. And then we have the LiDAR mounted on that. So the LiDAR will detect distance. If we measure the table, nothing on the table should be further than 1 meter. So then if we detect something under a meter, when the previous point wasn't, then we know that we hit an object, so we can know the first and last point of the object, take the distance from those past its algorithm, and measure the size of it. And then from there, Omar wrote some code to display where on the table it was.
So to shoot the duck down, we have to be very precise, right? So we don't have to waste ammo, we know where it is exactly. So even if it's in the dark night, we still know by looking at this right here, we know where it is. We'll also know the distance and the size of it. So we know if it's a big duck, we need like 2 bullets or something. If it's a small one, maybe 1 or 1. So that's pretty much how it works. Also, this place is supposed to show where we are located, so it was blinking before, and we'll blink somewhere over here, i.e. right here, and then the LiDAR sensor is going to represent, it's going to turn 180 or so, and it's going to represent, it's going to be like 1 dot on this grid to show where the duck is. Yeah, passing it to Kurt.
Alright, I worked on the little LED strip down here. So what this does is essentially it maps the current angle of the servo to a linear line along this strip, so we can tell exactly what sector it's scanning. So 0 degrees will be here and 180 degrees will be here. And as it sweeps across, it will light it up, and if it detects something, it will light up in a different color, red, and the brightness of that pixel will be determined by how close it is. So it's just another heads-up display in addition to our map here. Yeah, and the other thing is we have our, this is our buzzer, and so that will let us know if a duck has been detected by the system, and it will alert us. And the frequency will also be indicative of how far away it is. So we're going to talk about some improvements for next time that we could have done. So one of the issues we ran into actually was that the Arduino, the code that we compiled was barely over the limit of what we could compile into the Arduino, so we would take that into account for next time, reduce our code size, be a little bit more efficient with variables. Yeah, so we would, another thing is so we didn't take into account how many GPIO pins we have in the Arduino, and so we tried to use both 7-segment displays, but they take up a lot of pins it takes up, so we only end up using one of them. Yeah, and the final thing is we basically had everything together, but we had all the individual components. Sorry, yeah? Okay. individual components, but we just needed a little bit more time to put it together.
Yeah, so, group design is again, like, things could change. I think we had a really good, idea of the scope we wanted to get. The main issue I think we ran into is we should have changed, designed all the parts at the same time and then put it together at the end. And then we kind of, and then there's a little bit of problem because we weren't able to wire up some things, all here last minute. If we're doing this again, I think we would do this again, harder steps. So first things first is, you know, get the buzzer going, you see it done, and then we can do this one at a time, which will like ensure that we have at least the main systems working as we had all the systems and design everything as we're putting in once.
The reason it is not working is because our servo wires came out through transportation. So there's no ground or 5 volts connected to the servo right now. Those wires were in place. It should work. That's all I know.
If you plug it in right now, yeah, hopefully.
So it spins 180 degrees. The LiDAR should be scanning.
Another thing happened in transportation, we knocked out all the agencies.
Yeah. There was also kind of displaying that for a quick second, that two LEDs in the back. I don't think right now. So they should bubble the code, so we have like maybe 10 more minutes or so.
That's the problem is, like, bringing it all together last minute and wiring it all up, didn't allow us to actually make sure we have clean wiring, that if we transport it somewhere, that it's still actually together. So like, it kind of most of it was there, it's just an issue with like, we should have dedicated more time to the final like wiring up, making sure it's clean, just to make sure that if we start transporting it from one place to another, it actually stays together.
Good. It is displaying some numbers, and that should be the distance the thing is.
So we can put your hand in place. Yeah, so.
But it should display the distance and then the X and Y coordinates on the page.
You're pretty much land.
Any questions? You have
We were going to, because we were able to, with the math function, detect the size of it. So if we had more time to troubleshoot, we could have printed the size of each stub and then just added its statement.
So the plan was to, if we display the size, then it would be up to the officer who is currently on duty to determine, you know, the danger levels that are consumed to be able to display. Obviously, so we'd expect they would have an idea of the size of that might come through. And so with all the information that all the information we give them, then they'll be able to determine the threat. That's what we're doing.
What prompted such a violent approach to dealing with the dogs?
The prop says that Dr. Eagle sending the ducks here, and anyone named Dr. Eagle probably has nefarious purposes and should be dealt with violence. Yeah.
Do you have any measures to make sure you don't put the ball inside the duck?
So all I think this does is get as much information to the officer as possible. once that's handed to the officer, it's up to the officer, up to the officer and assistants that they, that they have in place to decide what the best course of action to do is. It only scans on the one plane.
Thank you.